Hello, my name is Julia Tosti, and today I will be discussing the experiment of the iodine clock reaction. So for this experiment, there were a few different materials that were absolutely needed in order for it to occur properly. We did use distilled water, but the main ingredients that were needed were the 1,000 milligram tablets of vitamin C. I used 2 tablets of that crushed down into an almost fine powder, just enough where there weren't large chunks of it left in the solution. I also used a 2% iodine tincture. I used about 60 milliliters of that. And then I used approximately 0.4 grams of cornstarch. The amount might not be exactly that, but as long as it was around that, the experiment should still work just fine. And then I also used 150 milliliters of hydrogen peroxide. So with those materials, 2 solutions were first created. Solution A consisted of the crushed vitamin C tablets and distilled water, which that was then filtered out until it was almost a clearer liquid, just to get all of that stuff that's in crushed pills, like fillers, different things like that, just to get that out so that we have mainly the vitamin C. So once that was filtered out, the iodine was added, and the solution returned being colorless, which is a good indication that you have the proper amount of iodine put in. If the solution does not return to being colorless, there's probably too much iodine in. Again, it could still be less iodine if it returns colorless, but as long as you don't have too much, the experiment again should still work properly. And then we added distilled water to that to make the solutions even. So then for solution B, this consisted of our cornstarch and water, which that was then heated in the microwave just to mix the solution a little bit better. It kind of breaks down the cornstarch into the water a little bit better than just mixing it. Excuse me. And then this solution was also filtered out, again, just to get a clearer solution, and the hydrogen peroxide was then added. So once these 2 solutions were individually mixed, I then took equal parts of both solutions and mixed them in a separate container, which we will see the results of on the next screen. So in this video, I did speed it up a little bit and trimmed it down just to save some time, but the overall reaction took approximately 4 minutes to occur. It generally should probably take a few minutes tops, probably even just a few seconds, but this increase in time can be due to a lower amount of iodine that was added. It was supposed to be 60 milliliters. I'm not sure if, I believe my bottle was a little bit lower than that, so that could be why my reaction took a little bit longer. Also, to speed up the solution, I could have added more hydrogen peroxide, which also would have saved time, or if I heated up the solution, but we'll go over why that is on the next slide. And another possibility could just be too much vitamin C. Again, that's another factor that could cause the reaction to take longer. But we're going to discuss everything on the next slide here. So what's actually happening in this solution? So what's occurring is that there are actually 2 reactions happening at the same time, and they're kind of battling each other. So the first reaction, which we see at the top here on number 1, is what's occurring in our solution A, right? So what's actually happening in solution 2, in solution B, is the hydrogen peroxide is trying to oxidize the iodide, or the I-, back to the colored iodine, or I2. But the ascorbic acid wants to reduce this iodine, I2, to iodide, I-. So our ascorbic acid, which is our vitamin C, that's trying to reduce the iodine. I'm just going to reiterate. So in our solution A, the vitamin C is trying to reduce the iodine, I2, to iodide, I-. In our solution B, hydrogen peroxide is trying to oxidize iodide, I-, back to the colored iodine, I2. So since these two reactions are kind of counteracting each other, it's a very quick reaction, and I2 is actually not existing for very long. So vitamin C is actually consumed due to the excess hydrogen peroxide, so our iodine starts to accumulate. The I2 then complexes with the I- to form triiodide, which quickly complexes with our starch, and this forms the blue starch iodide complex that we see at the end of our reaction. Increasing vitamin C can slow down the reaction because we need an excess of hydrogen peroxide, right? So if we increase vitamin C, it won't be consumed as quickly because it won't have big of a difference between the hydrogen peroxide and the vitamin C. By increasing temperature, this increases the rate of the reaction because by increasing temperature, it increases kinetic energy. So as you can see, by changing the concentrations of these reactants or changing the temperature of the mixture, it can really determine what that rate of this reaction will be. So from this experiment, we can really determine the effect that catalysts and temperature play on reaction rates, and we learn a little bit more about kinetics. So that's the end of my presentation. I hope you enjoyed it, and thank you for listening.